So let's take for granted the existence of the concrete, familiar, material objects of our world like tables and chairs, rivers and mountains, stars and galaxies, persons and other animals, objects that have particular features like shape and size, that occupy spatial locations, objects that we can see, that we can touch or imagine touching. These concrete things exist. The question that concerns us now is, in addition to these concrete material objects, what else exists? Doesn't 144 have at least one square root? Aren't there fractions, at least some of which are less than 1 and greater than 0? If these claims are true, if we believe mathematics is a true theory, then Quine's method seems to entail that we're committed to the existence of numbers. And if we believe numbers exist, then we must believe that there exist at least some abstract objects. The prime numbers, the evens and the odds, the fractions and the rest are certainly not concrete entities. They're not the kinds of things that occupy spatial locations. We can't see or touch them. They don't have features like shape and size, at least not in the straightforward sense that tables and rivers do. Indeed, we can ask the same question about all of the objects of mathematics, the perfect spheres of geometry, the vectors and groups of algebra, the sets of set theory. Do they exist? And if not, are we forced to say that mathematics is simply false? We will address the ontological status of mathematical entities later. First, we'll look into a more general argument for the existence of abstract entities. Should we believe not just that there are round tables, but that, in addition, there's an abstract entity, roundness? Should we believe not just that there are electrons, but that, in addition, there's an abstract entity, negative charge? Properties like roundness and negative charge would be interesting kinds of entities if they existed, not just because they're abstract, but because they may be examples of a kind of entity that is especially puzzling. They seem to be examples of universals, entities that are repeatable, capable of being instantiated at different locations at once by several different entities. Think about roundness. How many things in the area around you right now are round? The rim of a coffee mug? A doorknob? The button on someone's iPhone? There are many, many round things in any given place at any given time. And if we think that, in addition to these round things, there's also an abstract entity, roundness, then this entity will be a universal since it is capable of being instantiated in all of these many different places at once. And instantiated is our fancy term for saying it finds itself in these different instances. Properties instantiated at many different locations are interesting because when they're instantiated, they appear to be wholly present, as in the sense of whole here, right? W-H-O-L-E, at each of these locations. It isn't that it is part of roundness that it is present here in this coffee mug, and another part of roundness that is present there in the doorknob, as I might have a part of my body, my torso, leaning against a chair, and another part of my body, my feet, propped up on a desk. When roundness is instantiated at a given time, it is entirely present in all of these different locations at one and the same time. All of it is there in that mug. And all of it is again there in that doorknob at the same time. Now, Plato, whom you might all know, and Aristotle, his student, both believed in universals, but they conceived of them in different ways. These views are still among the basic ones today. So they both believed in universals. They believed in this stuff. Plato believed in universal entities he called the forms. These were the fundamental entities in Plato's ontology. Some examples of the forms are features like beauty, justice, and the good. And notice we put capitals on those because they're not just like individual good things. It's just the good. And it's not individual just acts. It's justice. And it's not individual beauty things, but beauty itself. Plato believed these universals had several interesting features in addition to being repeatable. So we mentioned that they were repeatable. Also, they are transcendent in the sense that they exist outside of space and time. And they are ideal, which means there are perfections. The forms of beauty, the form of beauty is entirely beautiful, not at all ugly. The form of justice is entirely just, not even slightly just. This is in contrast to those things in our spatio-temporal realm that may instantiate beauty or justice, concrete things like people, works of art, or political institutions. These things are never perfectly beautiful or perfectly just. According to Plato, although people and political institutions may instantiate the forms of beauty or justice, they always instantiate a little of the opposite form as well. Even the most beautiful works of art, the most just political institutions, are just a little bit unbeautiful or just or unjust. Finally, Plato held that the forms were the kind of entities that could only be known through the pure intellect, and never through sense perception or observation. Now, Aristotle, who was Plato's student, who's also a very, very smart and influential philosopher, took universals out of the transcendental realm and viewed them as existing in the concrete objects that instantiate them. This is to say that Aristotle viewed universals as immanent as opposed to transcendent, instantiated in space and time, and located where the objects are that instantiate them. So if you ask Plato, where's beauty? He'll point to the beautiful things. Aristotle. If you ask Plato, where are the beautiful things? He'll point upward to the sky. Actually, you know what? I'm going to leave myself a reminder to put in a picture of the School of Athens. Does everyone know Raphael's fresco, The School of Athens? Immanent, that's the view with Aristotle putting his hand like looking at the world. Transcendent, that's the view of Plato pointing up because it's nowhere in particular, right? So if you were to ask Plato, where's the number 3? He'd point up. That doesn't mean it's in the clouds, right? He'd point up to something that's not accessible to our sight. And Aristotle would be like, no, the particular 3 things, like collections of 3s, this collection of 3 things, this 3 apple, this 3 bananas, these 3 cars, these 3 kids, that's where it is. It's immanent. The universal does exist, but it's located in the things that instantiate them, the things in space and time. So for Aristotelians, we learn about which universals there are in the same ways that we learn about the particular entities there are. If one is a naturalist, that's someone who takes science as the means of doing metaphysics, essentially, as many Aristotelians are, one will think that one learns about which universals there are by consulting our best scientific theories. So Aristotle is the founder of biology and logic. So you know you're pretty smart when you founded a discipline, and he's the one who founded both biology and logic. So really, really smart guy. And notice how these are things we typically assume are at opposite ends of the spectrum. Biology is, you can't get more concrete than that. In logic, you can't get more abstract than that. And it gives you a sense of Aristotle's, let's say, mental abilities, that he was able to span that entire spectrum. So I'm not going to hide the fact that, yay, Aristotle, I'm a big Aristotle fan. So realism about universals is the view that there are such things as universals. So that's an ism. I'm putting it in highlighted here because we want to be using this as a technical term. When we're going to be talking about realism here, we're going to mean the view that there are such things as universals. Platonism about universals is the more specific view that there are such things as universals, and they have some or all of the features that Plato thought they had. So Platonism is a more narrow version of realism. It's a realism, and you agree with the account that Plato gave. And remember what we just said about Plato. He believes they're transcendent, they're perfect, and they're known only through the pure intellect. So if you're a realist about universals, and you moreover buy into these 3 claims, then you're not just a realist, you're also a Platonist. So you're a Platonic realist about universals. Now, realism or Platonism about universals is usually contrasted with nominalism, a position that denies the existence of universals. Now, nominalism, just so you know, goes back to the word nomen, which is Latin for name. Nominalists believe that universals just are names for things. The names are multiply applicable, but there's nothing more real to them, right, than that. So that's where it comes from. I think it's a kind of an unfortunate label, but we are stuck with it. So that's what we call, like you would have called it, like say, anti-realist about universals or non-realist. But nominalism is the position that denies the existence of universals. So remember those terms. And realism is also historically contrasted with conceptualism, an intermediate position between realism and Platonism and nominalism. The conceptualist rejects nominalism and says that universals do exist. However, she claims that universals are entities that depend on our mind's grasp of them, are abstracting them in the psychological sense away from concrete objects. According to the conceptualist, universals exist but are mind-dependent entities. Whether this is a tenable position is another question. Because, of course, one of the ways in which we tend to think that something exists when we say something is real is it's mind-independent. So if you say that some things exist, but they're mind-dependent, you kind of like saying an oxymoron. So it's not clear whether conceptualism is a tenable position. It could just be crypto-realist, like trying to be realist but hide it and not own up to the bad consequences of it. Or it could be nominalist and also not going to own up to that. So generally in the profession, folks think this is not a tenable position. It's like if I said, did it really happen? And then it says, well, it depends on what you think. Like, can you imagine that? Like, imagine I say, so did your father beat you? And then when they say, did your father beat you? Like, did it really happen? Like, they want to find out whether it really happened. As in, if there was a camera in your living room, would they have recorded someone striking you? Like that kind of, that's what they mean. Did it really happen? And then if someone answers, well, it depends on what you think. Well, that's not what I mean when I say, did it really? The really is meant to say, apart from anyone's beliefs, apart from anyone's perceptions and so on, did it actually really occur? And so it's unclear whether that's even a tenable move to make, right? So in general, those calling themselves realists about some class of entities will usually insist that the entities with which they're concerned are mind-independent entities, that the entities in question exist and they would exist even if there were never any humans around to think about them. So that's what I just said a moment ago, right? So typically that's what we mean when we mean something is real. We say it's mind independent. That's why conceptualism, you can imagine, kind of doesn't hold up. And so even for Plato, who thought that the only way we know about the forms is through the intellect, remember that's one of the three things we looked at a moment ago, these entities are robustly mind independent. The forms would exist even if there was never anybody around to think about them. So, by the way, what was written over the door of Plato's Academy? Does anyone know? The Academy was Plato's school, and there was something written over the door. This is like really famous. There was a warning right over the door. He said, "Let no one enter here who doesn't master geometry." So something along those lines in ancient Greek. So for Plato, geometry is really important because that's how we get to know the forms. The more you do abstract geometry, the more you get to know the forms. So that's a very mind-involved activity, right? You have to be smart, you have to practice. But still, the objects that you learn through geometry, they're there before you learn about them. The Pythagorean theorem is there before you learn about it. It doesn't thereby come into being just because you learn about it. It was doing just fine before you learned it, and it was doing just fine before Pythagoras formulated it. And so the mind independence is a very important criteria typically when we talk about realism. I don't know what Aristotle would have put over his school because he didn't have a school. You know what Aristotle did? He didn't have a school. What did Aristotle do? While we're on our big philosophical heroes of the Western tradition, Aristotle didn't have a school. How was his school? He didn't have a door to his school. He taught Alexander the Great. And what did Aristotle do? He didn't have a school. He walked around. So they're called the peripatetics, which means the walking around people. He would just walk around. So his school was taught outdoors. So when you went to his school, he'd be like, let's meet at KPU, but then we're going to go for a walk. And then he'd just blab and look at this and, hey, how about this? And he just walk with his students. So yeah, kind of like Socrates. Although Socrates, I would imagine, kind of sat down and he was in the polis. He was in the polis. He was in a city. Aristotle really was out in nature. And so his school consisted of just walking around. So again, still that reflection of, staying indoors and studying geometry, that's pointing up, that's Plato. And, walking around and looking at particular things, that's Aristotle. All right, so the classic argument found over and again in the history of philosophy for realism about universals is what is known as the one over many argument. Let's start by considering one particular example. Premise 1, there are red houses, red roses, and red sunsets. And this is true. So you want to take a true premise and you want to see what you can extract from it. Therefore, conclusion, these houses, roses, and sunsets have something in common, namely the universal redness. Sometimes we'll put the capital on it just to point out that when we're talking about the universal. Very simple argument, but also because of that, very powerful. What makes this an example of a one over many is that the first premise of the argument is a simple statement about a group of objects that bear some similarity. In this case, we have three kinds of objects: houses, roses, and sunsets that are all red. In addition, for this to be a one over many argument, in the conclusion we inferred that there is a universal, a one, that runs through these objects, the many, and this is what they have in common. From the fact that several objects, a many, have some similarity, it is inferred that there is a one that runs through the many and accounts for the similarity. That's why it's called one over many. The argument, we may assume, always takes roughly the following form. Premise: there exists some x that is f. Remember, just something you could put on the table, and it's f. And there exists some y, something else, that you could put on the table, at least one, and it's f also, where it's assumed that x and y are distinct entities. Therefore, there is a universal f-ness that the x and the y both instantiate. So that's the one over many argument schematically. We may allow multiple instances of this argument. Here are some examples. There are red houses and red roses. Therefore, there is a universal redness that the houses and roses instantiate. There are two chairs in this room, chair 1 and chair 2. Therefore, there's a universal chairness that the chairs instantiate. There are people in this room, and there are coffee mugs in this room. Therefore, there is a universal in this roomness that the people and mugs instantiate. That's what they have in common. There are flower pots that have a mass of 1 kilogram, and there are dumbbells that have a mass of 1 kilogram. Therefore, there is a universal mass of 1 kilogram that these flower pots and dumbbells instantiate. Now, if Plato is willing to countenance universals, that means take as true or take as existing universals in any case where there is a multiplicity of objects falling under some common term, then that will result in what metaphysicians call an abundant theory of universals, right? So if he is willing to countenance universals in any case where there is a multiplicity of objects, then you'll get an abundant theory of universals. An abundant theory of universals is a version of realism that posits a relatively large number of distinct universals. So for instance, mass of 1 kilogram, being in this room, chairness, right? These are, if you think there's one for each similarity, then that's an abundant, because you're going to have a very large number of distinct universals. However, there's an alternative view. Some may think we should restrict the allowable instances of the one over many, because you can imagine this starts to violate Occam's razor a bit too much. So for example, Armstrong, this is David Mallet Armstrong. I can write his full name here. David Mallet Armstrong, he's an Australian philosopher, good metaphysician, has argued that we should restrict instances of the one over many to cases in which the objects in the first premise are genuinely similar in a certain respect. This will lead to a sparse theory of universals. Sparse is the antonym or contrary word to abundant. So lots and then few, right? Sparse means few, right? And abundant means lots. A sparse theory of universals is a version of realism that posits a relatively small number of distinct universals. On an extreme version, and actually this is the kind that Armstrong himself proposes, there are only universals corresponding to the types of entities recognized by our best physical theories. So, for someone with a sparse theory like this, the only legitimate instance of the one over many would probably be the last one we looked at, where the argument supported the existence of the mass 1 kilogram. So according to this, you shouldn't have, let's say, this is unacceptable. In this roomness, you should shave that off. But this mass of 1 kilogram, that you're going to have to put in the mix, right? Because the science is needed. So you only follow up on this one over many argument, only for instances where what the similarities are tracking are really, really vital similarities, not trivial similarities. Because you can imagine being in this room, that doesn't say much about coffee mugs, but being a mass of 1 kilogram, that says a lot about the flower pot or the dumbbell. It's much more essential to them, and this is much more accidental or inessential. So there's an argument against realism now. So remember, what we mean by realism is the idea that there are or there exists universals. Here's an argument. Now previously, because we saw just the one over many argument, right? We introduced a rigorous method for determining the entities that one is ontologically committed to. So that's what we learned for the first month. Let us now consider that method, like what that method has to say about the one over many argument. So using Quine's method, remember Quine's method has those 4 steps. It's quite easy to see that the one over many, as it is usually presented, is an invalid argument. That is to say, in all of the examples above, the conclusion does not follow from the premise. The most straightforward way to show this is by regimenting the premise and conclusion into the language of first-order predicate logic, which you've learned to do. With this in mind, let us use the following key. X is m, that means X has a mass of 1 kilogram, so having a mass of 1 kilogram. P, that means being a flower pot. So let's go for pot here. I'm going to underline it, right? Mass, I'm going to underline this. And then D is a dumbbell. The first premise of the one over many argument, there are flower pots and dumbbells that have a mass of 1 kilogram. And notice this is the one that the sparse realist about universals was willing to countenance, may then be symbolized as follows. There exists at least one X such that this X has a mass, and this same thing is a flower pot, and there exists at least one other thing such that this other thing has a mass, and that other thing is a dumbbell. That's D as I want to use. Right? So I'm changing some of these things so that they snap a little bit better. From this, we know that we're only committed to the existence of those objects that you put on the table, needed to stand in as the variables, the values of X and Y. But the worldly things that we plug into the X and Y will both be concrete particulars. This flower pot and this dumbbell. Once we see the logical form of the premise, we can see that it does not commit us at all to the existence of a universal. We may say then that the conclusion drawn by the realist about universals simply does not follow. Like imagine I say that there is at least one thing that I could put on this X that weighs 1 kilo. If I want to show this claim to be true, I'm going to go ahead and I need to put stuff on the X. How many things do I have to put on the X to show that this claim is true? That some X weighs 1 kilo. At least one thing I could put there weighs 1 kilo. How many things am I going to have to find? If you task me as the cosmic concierge, how many things must I be able to put on there? At least one. At least one. All right. So as soon as I have one, I have a thing that weighs 1 kilo, right? But suppose, for instance, I get another thing that weighs 1 kilo, because there's lots of things that weigh 1 kilo. Am I then burdened with having a universal? No, not really. I can truthfully say of the first thing I put on there, it weighs 1 kilo. And then you give me a second thing. I'll send you all on a cosmic concierge assignment to bring me back 1 kilo things. Nigel, Xander, Devin, you all bring back different things that weigh 1 kilo. So for each one, we put it on the X, and I proclaim, it weighs 1 kilo. Good. It's true. Next, I put it on there, and I say, it weighs 1 kilo. Good. Next, it weighs 1 kilo. We are saying truthfully of each individual thing that it weighs 1 kilo. Nothing in this commits us to thinking about universals. All we're handling are particulars. I'm putting particulars on the table, and I'm making particular claims about them over and over again. Let me say that again slowly. If someone says there's some things that, multiple things, like let's say, not just some, but let's say 20 things at least weigh 1 kilo. and we go over those 20 things, each time I'm putting a particular thing on the table and making a particular claim about it, namely that it weighs 1 kilo. And nothing prevents me from saying that sentence again. If you give me a second thing that weighs 1 kilo, I can say of it, truthfully, that it weighs 1 kilo. That way, we notice here, we're not at all presupposing universals. Even if somehow we were to do the whole list of everything that's 1 kilo, we still could handle them all individually. All individually. Kind of like Quine when he was talking about tigers. At least one tiger, he meant the damn tiger, the one that has a weight of which you can truthfully say it's a tiger. You could say of it that, and you can do that for another beast that's also a tiger. It's a tiger, and he did that with the individual tigers, individual lions, and they were able to make offspring. Likewise, if we did this, let's imagine we're going to do this twice over. I put an apple and I say truthfully about it that it is red, and then I put a rose and I say truthfully about it that it is red. So I put that on the table. I can do that twice over. Why is it that I have to have a universal? Quine's method makes clear that what we're plugging into the X each time are particulars. Particulars. And for each of those particulars, we can say once again that it is red, and once again that it is red, and once again that it is red. But again, nothing in this commits us to redness at all. There's no need there to say that in order for me to say that there are two things that are red, let's imagine I'm going to run this experiment twice with the rose and the apple. Nothing there commits me to redness. I can put the rose, say it is red, deep breath, pause. Then I can rinse and repeat. Put the apple, say truthfully, it is red, deep breath. And again, I haven't mobilized any universals, just particulars. There is at least one X, such it has these things, and there's at least one Y, such it has these things. That's it. And remember, these capital letters just are saying truthfully about them. My little thought bubble here, right? Weighs 1 kilo, is red. There's no problem saying these things. All right. So now I've given you arguments. Well, we started, let's recap here. We had an argument for realism, and it was a venerable argument. It was the one over many argument. There are red houses and red roses. Therefore, there is a universal redness that the houses and roses instantiate. So this was an argument for realism. You might conclude, dang, I'm going to need to say real universals exist. Then we used the method we learned last month, and we realized that, wait a second, I can put a particular thing, and I can say of it that it has these attributes, and I can put another particular thing, and I can say of it that it has these attributes. Like in the case of redness, right? I can say, let's say that there exists an X such that this X is red, right? And I can also say that there exists a Y such that this Y is red. Yeah, cool. And I can also say that there exists an X, a Z, right, such that this Z is red. Yeah, true, right? And each time what I'm plugging in is a particular thing, a particular thing, a particular thing, and it's not clear why. Just because I said is red, I've said it now, you heard me, and I say is red, I said it again, is red, I can say it again, and I can say that for each item that you put that fits the description, it's not clear why I need a universal. So now you might think, oh, you're right, I don't really need universals. So under the weight of Occam's razor, I really shouldn't have any in the mix. So those are arguments now against realism and for nominalism. So now let's go back and forth, and I'm going to give you an argument against the last argument against realism that we just saw. So are we clear on the dialectic here? We had an argument for, an argument against, and now an argument against the argument against. Type in yes if you're following what I'm saying, lost if you're lost. So yes or lost. Just want everyone to track the arguments here each time. So we're sharp break here so we don't get confused. That team wins. No, that team wins. And then the ball goes in that camp and so on. All right. So realists like David Armstrong are aware of the previous critique. So they know all this stuff. Like, by the way, Armstrong, he's done a course like mine. He knows Quine's method. He knows how to do logic. He's no fool. He knows all this. Right? But they nevertheless insist that on a proper understanding of the one over many argument, it is valid. According to Armstrong, we need to posit some universals because true sentences about a mass of 1 kilogram require an account of what there is in nature that explains the similarity. This commitment is the consequence of a more specific position called truth maker theory. This theory is based on the truth maker principle. And notice, just again, remember the first step of Quine's method is that we have to assemble all the sentences we take to be true. So you want to get an accurate picture of the world, which is what metaphysics tries to do. We're going to have to get started somewhere, right? Say observation can collect all sorts of things, and then you sort of generalize that into statements. Fair enough. And you take all the statements you take to be true, right? Well, this is truth maker theory. Truth maker theory is based on the truth maker principle that says that for every truth, there's some entity or entities that make it true. So if I'm going to say truthfully that it does weigh 1 kilo, there has to be some truth out there that makes it weigh 1 kilo. And if the other thing also weighs 1 kilo, there has to be some truth out there that makes it weigh 1 kilo. And if both weigh 1 kilo, it's the same truth that makes it weigh 1 kilo, the same truth maker. Truth maker theory has become very popular. We will see it come up again in different subjects throughout the semester. For now, we can just note that when a truth maker theorist looks at a sentence that he or she takes to be true, for example, some houses are red, or this flower pot has a mass of 1 kilogram, he or she will claim that there must be some entities that make this sentence true. That's truth maker theory. Let's have some fun with truth maker theories. Again, I'm going to augment this. Let's just look at what's here, and I'm going to ask you just again, just the items. This is the claim. The items in the box, the top box, resemble each other more than they resemble the item in the bottom box. True or false? Nothing fancy here. Let's be honest with ourselves. The items in the top box resemble each other more than they resemble the items in the bottom box. True or false? Clearly, it's true. I'm hearing from Jaden and Devin, but again, don't be too sort of cautious here. Again, we want to do philosophy, but let us not doubt in philosophy what we know in our hearts to be true. Clearly, they resemble them more. You could cash that out, by the way, if you were scared of reporting on how you're observing things. You could cash that out in psychological experiments. Like, what do you think would be the percentage of subjects who submitted to this visual stimulus would agree to this claim that the items in the top box resemble each other more than they resemble the items in the bottom box? If we were to do a psychological experiment, you put subjects in front, and I take 1,000 subjects and I ask them, which are more similar, the thee to the thee or the thee to the ad? Like, what do you think would be the number of subjects who'd agree that the thee and the thee look more like each other than the thee to the ad? Like, I didn't run the experiment, but what would you think? Like, imagine you wanted to test the truth through some psychological or social science method, right? It'd be like 100%, right? Like, everyone would agree on this, right? Like, as 100%. Like, anyone seriously? Like, exactly. This, we can't doubt this. This is the gold standard. It's as good as it gets, right? It's more resembling, and also more resembling also for AI. If you know about AI learning software, like AI learning software, like if you take Rosenblatt's, the guy who invented what we call now the architecture of connectionist networks that AI and use back in the 60s, whatever. You put an AI on this and you train it, it'll see the thee and the thee as more similar than the thee and the ad. It's like, all right, so you know this. Subjects under controlled conditions know this to be true. AI would also corroborate this. Clearly, the items in the top box resemble each other more than they resemble the item in the bottom box. And likewise, this sentence, the items in the top box resemble each other more than the items in the bottom box. True or false? Everyone chime in. It's clearly true, right? Like, only if you're on crack or you've taken too much philosophy would you doubt this, right? It's like, yeah. All right, so truth maker theory is going to say, if this is true, then there has to be something in the world that accounts for the resemblance. That's what the truth maker theorist is going to say. Like, for each truth, there's a truth maker. There's a thing out there that makes it true. Like, suppose I say Justin Trudeau weighs 90 kilos. What's the truth maker of that claim? Justin Trudeau weighs 90 kilos. What would be the truth maker of that claim? What's the thing that would allow the sentence to be true out in the world? A scale, that's an instrument. We need more than the scale. We need a certain person. So I say Justin Trudeau weighs 90 kilos. That could be true, that could be false. What would make this true? Where's the truth maker? Does he live in Hawaii or does he live? It's Justin, good old Justin. And he'd have to be 90 kilos. If Justin Trudeau weighs 90 kilos, that's what would make that claim true. So Justin, in his 90 kiloness, would make my claim true. So if I say Justin Trudeau weighs 90 kilo, and it would also show it wrong as well, because if he doesn't, then it would show it false. It's also like a false maker, right? If you do philosophy of science, we want to falsify certain claims. Yeah, he'd have to weigh himself, but he has his weight before we discover it. You agree, Shane? Before he weighs himself, whatever weight he has it. The instrument's important for us to know and access that fact, but the fact is there prior to its being assessed. You see that, Shane? Does that make sense? Like before you step on the scale, you have the weight you're about to reveal, but the revelation doesn't bring the weight into existence. You weighed what you weighed before you stepped on the scale. Exactly. Again, last one here, right? And again, just to highlight how truth-maker theory is a very strong argument in favor of universals, the items in the top box resemble each other more than they resemble the items in the bottom box. And again, notice here, it's not so much that I'm asking whether or not humans resemble each other more. I'm asking resemble the items in the bottom box. Like the eggs resemble themselves and humans resemble themselves, but the eggs resemble themselves more than eggs resemble humans. Let me write it that way. Eggs resemble each other more than eggs resemble humans. True or false? Seriously, right? Like totally true. All right, so we agree that that's true, and that's a paradigmatic exemplar of a true statement. You can't get better than this. All right, so okay, let's not go for the exotic cases. Let's get clear on the clear ones. And then, so the idea is there has to be, according to truth maker theory, there has to be a truth maker in the world that makes that true. There has to be there's a true similarity that exists. And I'm biting down on the word exists here because that's the word that we metaphysicians are tracking. We're not so much concerned about knowledge, but rather with existence. There really has to exist a similarity. There really is a similarity. And I'm using is as the verb to be. That's our verb. All right, cool. Let's keep on moving. All right, so here's now another argument, different from the ones we've seen, in favor of abstract entities, so in favor of universals. Let us now consider a quite different way to argue for the existence of numbers and other mathematical objects, one that has been more influential over the past decades. This is via the indispensability argument. The indispensability argument is historically associated with Quine and Hilary Putnam. That's a guy, by the way. It is an argument for realism about mathematical entities. Realism about mathematical entities is often called Platonism in the philosophy of mathematics literature. We may state the indispensability argument with the following two premises, in the following form with two premises. We ought to have ontological commitment to all that is indispensable to our best scientific theories. And you know what? Guess what? Mathematical entities are indispensable to our best scientific theories. Therefore, we ought to have ontological commitment to mathematical entities. Now notice here that the first premise follows from a commitment to naturalism. A naturalist is someone who believes that one should use our best scientific theories in order to settle questions of ontology. The second premise is a substantive claim about our best scientific theories, since mathematics is a pervasive element of all the sciences, from fundamental physics to biology, and even the social sciences, such as economics and political science. So the idea is, if you ought to turn to your best scientific theories to do your metaphysics and your ontology, and if those theories themselves rely on mathematics, then you have to basically say that, yeah, the mathematics is kosher. It should also figure into your ontology. Now, the indispensability argument essentially pivots on the idea that quantification over mathematical entities cannot be paraphrased away without doing damage to the explanatory success of these scientific theories. Like contemporary physics, do you think you could do it without math? Yes or no? Like imagine a complete ban on math and you try to do contemporary physics. You think it could be done? Yes or no? There's no way. There's no way. I couldn't even begin to say most of the major views theories and whatever in most of these fields without resorting to some math. That's what we mean by indispensable, cannot be dispensed with. And you can't paraphrase it away either. It isn't like there's some purely qualitative jargon that we could transform the quantitative stuff into. That's why if you do natural science or any of the sciences, you have to do quantitative methodology. And if you do some social sciences, you have to do stats. Even psych, right? You got to do stats. Anybody ever do stats or quantitative methodology? Type in yes if you have. Yeah, sadly, yes. It feels like a doctor's appointment, right? But you got to do it because it's indispensable. And the idea is like, what the hell were you doing in that class? Manipulating numbers. All right, well, if numbers aren't real, how is that? Think it'd be miraculous according to truth-maker theory. It would be miraculous. Let me say this slowly. It would be miraculous according to truth-maker theory if the math wasn't tracking something out there in the world. But if it was true without a truth-maker. What is especially interesting about this indispensability argument is that it gives one a way to see numbers and classes, indeed all of the mathematical tools used by our best scientific theories, as on a par with other entities that are far less controversial. Nominalists, those who deny the existence of abstracta, including mathematical entities, often motivate their position by noting that we cannot observe mathematical entities and so lack reason to believe in them. But what the defender of the indispensability argument can note is neither do we observe many of the entities posited by our best scientific theories. We can't touch electrons or magnetic fields, arguably. We don't observe stock markets or recessions either. Even so, we're justified in adding them to our ontology because of the role they play in these extremely successful theories in physics and economics. By the way, a center of gravity, that's an abstraction. You have a center of gravity. Where is it? Then you point to your belly button. If I take your belly button and I cut it out and I put it in a jar, is your center of gravity in my jar? Let me say that again. You have a center of gravity. Let's say it's located right about your belly button. And I take a little flesh sample and I put it in a jar and I walk away with it. Did I walk away with your center of gravity? Yes or no? Absolutely not. You're absolutely correct. I didn't walk away with your center of gravity. There it is. It's in the jar. What are you looking at, Mom? Oh, that's my center of gravity. I took it out. I had it removed today. I had my center of gravity removed and put in a jar, and we're pickling it. Really? That's really crazy and gross. No, you still have a center of gravity. It's an abstraction. But we use centers of gravity all the time. Like if you want to measure the influence of the moon on the tides, you have to use the moon's center of gravity. Because the moon is a sphere. It's got three-dimensional shape, and it pulls in different directions, has a mass, and so on. And so you want to say, well, here's its center of gravity. And it does literally have a center of gravity, but it's not like you'll ever observe it. We dig into the core of the moon, and we grab the little pebble at its core. We go, there it is. I'm holding it. It's the center of gravity. And we take it to the Smithsonian Museum. Centers of gravity, man. Like they're everywhere. We use them all the time. But again, the idea is that's an abstract entity, and we don't see it, but it's perfectly fine because we need it, right? So despite their indispensability, we still have good reasons to doubt that abstract entities exist once we consider their bizarre properties. Indeed, if one believes that at least some universals exist, as sparse and abundant realists do, then one believes that there's at least one thing, say the number 3, which can't be perceived. There's at least one thing, say the number 3, which has no spatial extension. There's at least one thing, say the number 3, which is outside time. And normally if we say it can be perceived, and we say it has no spatial extension, and we say it's outside time, we tend to conclude that it doesn't exist, right? Like imagine I said Bigfoot exists, but he can't be perceived. He has no spatial extension, and he's outside time. That gives you good reasons for disbelieving in Bigfoot, not believing in Bigfoot, right? There's good reasons to think that it doesn't exist. And yet, these arguments, the indispensability argument, the truth-maker argument, the one over many argument, tell you that things like the number 3 exist. But then you find yourself saying these things. And that's a little weird. Can everyone feel the pinch of that weirdness? We need to be mindful of that. Like, there's a real reason that motivates nominalism. Like, nominalism has what we call a good motivation, right? Like argumentation is one thing, but like there's real good reasons why you might want to say, I want to be skeptical about that. Not to mention, by the way, that if you put this, Occam's razor, right? We're not going to be too happy about that. Now you're extending your concept of the real to include things that have no spatial existence or is outside time. I mean, clearly it's hard to provide evidence for these claims, as the following illustration makes plain. Like, let's imagine, for instance, let's zoom in on my good old table. Now we have this really cool table that we can play with. If I say there is at least one X that you could put on this table such that it cannot be perceived. All right, so there you go. Find me something you're going to put on the table. So I'm sending you on an errand, and you know what? I'll give you $500. $500, cold hard cash. You come in, you put something on the table, and it can't be perceived, not even through instrumentation. Could anyone ever show up like, hey, 500 million bucks, put it on the table? It can't be perceived. That's really okay. Yeah, cool. I believe in angels. That's not right, right? Nitrogen, but again, Kyla, that's a good stab at it. You know, it's $500, but like imagine, like I can't see the air I'm breathing, so you don't need to go that far. So yeah, nitrogen, exactly right. But let's say that cannot be perceived in principle by any instrumentation, right? Through any means. You can perceive nitrogen, by the way. Like there's little tests you can do, right? Like when I mean cannot be perceived, that's a shorthand because I can't fit it all on there. Like even with instrumentation, or there's no, I'll never see it. Not I just don't see it, I'll never see it. Kyla, do you see that? See that distinction? Because there's invisible stuff all the time. My fart's invisible. My kids are really happy about that. That would really make things awkward if you were in a party, if we could see it, right? You can smell it, but you can't see it. So that's invisible. But I mean perceived, not just visible, like perceived in any way, right? That'd be a little weird. Likewise for this. Imagine I said there's at least one X that you could put on this table that has no spatial extension. What could we possibly put on there that satisfies that description? Again, what could be the value of the bound variable X? It's bound here, it's at least one, and I'm saying something about it. It has no spatial extension. Anybody have a guess? What could we possibly put there? Like, okay, suppose I want to believe you. Show me the evidence. There exists at least one thing you could put on the table that has no spatial extension. I mean, you could put a dot, but then it's a line without girth, but then I'd look down on it and I couldn't find it. Gravitational force, yeah, perhaps, but no, it doesn't. But gravitational forces work themselves out over space, I would imagine, right? We agree, Michael, that we have to scrape the bottom of the barrel and go into exotic, weird things, and we'd have to consult whether or not that's getting weird. I would think if it does lifting in physics, I'm no physicist, but if it does if gravitational force, yeah, if gravitational force does work to explain the material bodies and how they move, it has to somehow play itself out in space. Do you agree? Like somehow, like the gravity, nearness and farthness, distance is a relevant thing with gravitational force, right? Like when a rock swings around the sun, it swings in virtue of the gravitational force, and it matters to the rock whether it's close or far. Kepler's laws, right? The closer you are to the sun, the quicker your orbit. There's a reason why Mercury spins faster around the sun than, let's say, Saturn farther away. It's because it's nearer, and that has to do with space. So it's suitably massaged, if we understand what we mean here. Yeah, do you see that? Does that make sense? Again, I'm just riffing with this. It's not to say, so here's the thing, right? Look, let's say some mathematician says, yes, Mark, I'm here to reclaim. What did I offer? What was my last offer of money? 500. Did I bring up the money, or it's like $500? I think I said $500, right? Someone comes up to me, Mark, I'm a mathematician. I work in the KPU department, and I put something on your table. I go, really? What is it? He says, it's a line. Oh, really? But it's a line with no spatial extension, because you know that when you do geometry and you make a line, is the line supposed to have girth? Yes or no? So let no one enter Plato's Academy unless they've done geometry. If you make a line in geometry, the line you're going to draw has girth, but the line that you're trying to refer to, would it have girth? Would it have width? You know the answer to this, right? It's not just thin. It has no width. Your drawing is going to have a thin line. It's going to be thin. But if it's thin, it still has spatial extension. Do we agree, Kyla? Like a really thin line that requires a heavy-duty microscope. Nigel, is that a mind trip? You having a bit of a mind trip there? Yeah. All right. So Kyla makes a super small line with a I don't know, like an electron, I don't know, some small instrument, like the finest instrument you can muster. And it's really thin, and I need an even more powerful instrument to see it. But do we agree if I can see it through an instrument, it has spatial extension? Type in agree if you agree. You zoom in, you zoom in, you zoom in, you zoom in, you zoom in. But eventually, if you can see it, if it has width, you know, like if it bleeds, you can kill it. Well, if it has width, it has spatial extension. Yeah. So, but when you do a line in like technically speaking, when you draw a triangle in geometry, it's not supposed to have any extension. So like that's what we mean when we say the abstract entities. We don't mean your drawings, because you could put a drawing on the table. That's not contentious. Just like you can have the idea of Santa Claus is not contentious. It's the existence of Santa Claus, the jolly old fat man that we were concerned with. Not the idea about it or the word about it or our discourse about it. That's a sociological fact. It's a psychological fact as well. No doubt I have the idea, you have the word, and we have our practices. True, true, true. And no doubt those exist. True, true, true. Social facts are not less factual for that. They're facts nevertheless, and they exist. Like when I scream out something, that exists. That scream existed, right? But look, it's supposed to have no spatial extension. Is outside time. How long's the number 3 been around? When was it invented? When did it come into being? Who discovered the number 3? Do any of these questions make sense, or are they senseless? You know, this was when, you know, the number 3 was discovered. It's senseless to you, huh? So why is it senseless? The number 3 is outside of time. Kelly, you have kids. They're going to know about the number 3. Your kids are going to know about the number 3. Everyone's going to know about the number 3. Why? Not that it lives very long. It's outside time. The Pythagorean theorem, do we know what that is? Say yes if you do. Discovered by Pythagoras. Have some fun in that fresco by Raphael, looking at Pythagoras. Easy hint, right? You'll find him out. Pythagoras, by the way, was one messed up dude. I'm not going to go into anecdotes about Pythagoras, but look him up. Y'all think, well, I know Pythagoras, right? He must have been a good mathematician. He was one messed up cult leader. He was one messed up dude. Anyways, and he had a really strange set of beliefs. In any event, I won't go into those. Yeah, that's a really those anecdotes would take me far afield, but fascinating. The history of mathematics starts to bleed into Oriental mysticism if you go far back enough. It's just a complete mind trip, In any event, the Pythagorean theorem says that the square of the two opposite sides, right, add up to the square root of the hypotenuse. So you all know what that is. That was there before Pythagoras, right? It was there. It was there before. The question of before and after, it's still around, right? He can put his name to it because, kind of like Plato pointing up in the sky, he had an intellectual insight into it. He cracked the code. By the way, I believe the Egyptian architects were using right-angled triangles with sides that were 3, 4, and 5 to make their architecture. Because if you have a right-angled triangle that has an hypotenuse of 5, one side of 3 and one side of 4, that's a flush fit with the Pythagorean theorem, but they didn't compress that and crack the code. They didn't know the Pythagorean theorem. So all they would do is fractions and multiplications of that all the time. So this was the secret knowledge handed on to Egyptian, ancient Egyptian architects, right? But they didn't crack the code. The code was kind of waiting there to be discovered. There's a pattern to this, right? 3 times 3 makes 9. 4 times 4 makes 16. 4 plus 16 makes 25. Square root of that makes 5. That's the ratio. 3 sides, a side of the length of 3, length of 4, and hypotenuse for 5, right? And again, I'm probably need some visuals here because I think it's kind of helpful to do it that way. Hold on. There you go. 3, 4, 5, right? But that's not grasping the Pythagorean theorem. The Pythagorean theorem says that if this is x, and if this is y, and if this is z, right, that x square plus y square is going to equal, right, z square. And if you see that, like 3 times 3 makes 9. 4 times 4 makes 16. 9 plus 16 makes 25. And the square root of 25 is precisely 5. And you can just imagine if all you have, right, are this, you know, 3, you've been to school, they taught you that if you do this, you're fine, you got it figured out, but you haven't cracked this, you don't know this. But even if you don't know, let me put K for knowing, right, you don't know this, so tilde K, bubble all this, but you do know this, right? So this is where metaphysics and epistemology are different. The stuff here, K, is knowledge. You know this bubble over here, right? But you don't know this bubble over here. The Pythagorean theorem still awaits out there waiting for you to know it. So here's a truth maker sort of conundrum, right? Where is it when I say it's waiting for me to discover it? It's not like a fossil bone that's buried under the ground. The fossil bone that's waiting to be discovered is here now, and it has none of those spooky properties. It has spatial extension. It's not outside time. It can be perceived. But when I say, for instance, that the Pythagorean theorem is waiting to be discovered, where's this waiting room? Where is it? And you can see why that would be a little weird. And you don't want to discard the Pythagorean theorem from the mix. You want to say that that's a thing in some ways, right? Because so many sciences depend on it, and it's clearly not miraculous when we sort it out, right? We're clearly tracking something that must be real, but it's not real enough, and then it sounds to look really spooky when we describe it. My friends, that in a nutshell is the whole issue of abstract entities. Find yourself believing in something for which you can't come up with a shred of evidence. Doesn't that make you lose a bit of philosophical sleep at night? Like, that's what the nominalist would say, right? Doesn't that bother you a bit? Like, can anyone feel that that should be a bit of an item of shame for a philosopher, that they believe in something that can't be perceived, has no spatial extension, and is outside time? And if you're into religion, that's another ball of yarn. But in philosophy, like, and so now I really want everyone, because I'm looking at the clock and we're wrapping up, but I want everyone to at least meditate on this. So if you ever find yourself believing that there exists a thing for which you can't show a shred of evidence, that should give you pause. It should at least make you think that. And again, the endeavor is, okay, so on the terms of the debate here, we have Occam's razor. Whoever goes lowest without falling. Remember the game? What was the game? Limbo? How low can you go? How low without falling? What was the name of that game? Is it Limbo? How low can you go? The limbo, that's it. Limbo is also like when you're confused and you're floating in this weird, yeah. All right, so by the rules of the game of limbo, it's whoever can go lowest without falling. Hypothetically, if a nominalist manages to do all of the work that the realist does, but by paraphrase never uses a universal, who wins? Universalism, realism, or nominalism? The nominalist manages to explain everything the realism does, but via paraphrase never relies on a universal. Who wins that fight? Imagine the nominalist can really do that job. They can actually, everything you throw their way that you think you can explain, they can explain it too, but there's none of that ingredient in the mix. They're able to use paraphrase to say everything you say, recapture all the sentences you think are true and that we agree are true without ever using a universal. Who wins, the realist or the nominalist? Suppose a nominalist can do that. Suppose, it's a big suppose. That's a big promissory note there, right? It's a blank check. Right, the nominalist would win. Does everyone see that? If the nominalist is able to do everything you do, that is, account for the truth of all the claims we take jointly to be true, but without resorting to a universal, and through methods of paraphrase, makes those make sense, that'd be the goal, right? That'd be the goal. Same truth, but none of the weirdness.